I'm, I'm gonna make the introduction, and basically for the project we had to compare some historical stock prices for Google and Apple in part one, and in part two we had to do some analysis for the Black-Scholes model using a couple of the Greeks to look at how they change over time in relative sensitivity to time and to price, etc. So I did not do part of the analysis, I did the coding part. So I basically did the coding part for part one, and basically what we did was we used Professor Han's input file, and then from there I worked on creating the sorts using a bubble sort for the structure and for the independent arrays. And then after that, the one thing I did that I thought was a little different was I realized that the stock mean and the stock median were very relevant for other functions, so I actually put all of the mathematical formulas within one function to make it very efficient. I had a lot less variables and it called it very quickly. So I did that, and then I made my output do a couple of things on the screen, which I don't have, but Professor Han, you'll get it in the email. And now I will take it off to Rohit, who's going to explain a little bit of the analysis.
So we'll start with Google's and Apple's mission statement, just to get an idea of what what they're about. So Google's statement is to organize the world's information and make it universally accessible and useful. So the goal is to make information more available to people, so that's really important for them. And Apple is committed to bringing the best personal computing experience to students, educators, creative professionals, and consumers around the world through its innovative hardware, software, and internet offerings. So we see that they're more about providing product rather than providing organizing information. So they both have different business models. So Apple was founded in 1976 by Steve Jobs and Steve Wozniak, and they're traded under the ticker AAPL. And the IPO was at $22 a share, and it was at 1980. And they had a stock split 3 times through their history. And like I said before, they're known for making PCs, digital devices like iPad, etc. And they also make software like the iOS and the OS X operating systems. And Google was founded more recently in '95 by Larry Page and Sergey Brin or something. Yeah. And the IPO was at 2004, and the price was $85 a share. And they basically organize information, and they generate revenue from ads, online advertisements. And so this graph shows basically the price of Google stock in this date range, and we see some fluctuations. And as you go on, this is the volume, and we see a peak in certain places because this was due to product releases. So whenever they announce that they're releasing something, due to rumors, more people buy the stocks. This causes the price of the stock to obviously go up. And we see, so these are like more pictures, and this is Apple's price. So we look at the statistics now, and for example, first we'll look at these kurtosis. So a negative kurtosis means that so positive kurtosis means that the distribution is skewed to the left, and a negative means the opposite. And basically the function of kurtosis is to measure the volatility. So a better, like, skewness is also a good measure of how the distribution is tilted. So if it's negative, that means that the distribution is skewed to the left, and a positive means it's skewed to the right. So zero skewness would mean that it's a normal distribution without any skewness. So we see that when the skewness is positive, right, the mean is much higher than the median. So in this case, we see that this is happening. And then as we go on, we see that we again see that the negative skewness means that the mean is lower than the median. So we go on, it's negative, go on. So positive, if you go back, you see a positive skewness, right? And this means that the mean is more than the median. So,
it's a good way of showing how individual prices are pulling the average of a stock price around. So you can see that you can see the spread between the mean and median. You can tell, well, is it off to the left? Is it pulling them down? Is it pulling them up? So it's a good way to, I know they're not really used in finance, but statistically it's a good way to at least start when you're doing like in your pre-processing phase and you want to weed out some data to start with. It's good to see, okay, which ones are, what's the most volatile, what's getting pulled the most either to the right or to the left. So they're good to have, they're good to know.
and also a negative kurtosis shows that the distribution is more like skewed towards the left, right, I believe. Left distribution, and that means that the mode is more than the median, and the median is more than the average. And it's the opposite for the negative kurtosis, in which the average is more than the median, and the median is more than the most.
Okay, I'll take over from here. Thank you, Rohit. My part of the project dealt with part 2, which is the Black-Scholes model. This is something I want to talk about because it's often overlooked when we're dealing with programming, the Black-Scholes model. The Black-Scholes model is a guideline. These are what has to be true in order for the prices to be correct. We know that this isn't the case most time, and so when you're making decisions based on what the Black-Scholes model tells you, it's important to keep these in mind and to understand how if one of these aren't true, how does that affect what's really going on in your model. So these are what the assumptions are. You can all read them. Okay, now at the risk of sounding repetitive, these are what the Greeks are. Delta is the measure of the options price, the rate of change of the options price with respect to a change in the underlying price. Gamma is the rate of change of delta. And beta is a measurement of how time decay affects the price of the option. And vega is a measure of changes in volatility. Okay, so here we have a familiar looking graph after the last couple of presentations. So from the range of 40 to 100, we have the different call prices and put prices. Can you guys just tell by looking at the graph what the gammas and deltas are? I think it should be pretty simple. Here we see that for deep in the money call options right over here. So the strike price is right over here, and then the stock price is, let's say, 100. It's very much so in the money, and so a $1 increase in the price of the stock would increase the option price by about $1, and so your delta would be 1, which is about the slope of this line. Gamma you could see by trying to just look at where where the delta changes the most. So here, so basically from here to here, it looks pretty much just like a straight line. So your gamma is going to be really small. Here we see a large change right here. So right around the strike price is where your gamma is going to be really large. Let's move on. Okay, here we have graphs of the actual deltas. Your delta is always going to be between -1 and 1. For your calls, it's going to always be between 0 and 1. It's always going to be positive. And as I said before, the more in the money the call is, the more closer it is to 1, and then vice versa for the more out of the money it is. And gamma, we see here that around the strike price, it reaches its maximum point. And then on the outer edges, it's decreasing. If you go back one, we skip that one. It looks pretty much the same. Here we have a similar shape for the put delta. It's basically the same shape, but on the other side of the x-axis. And we see that it's always between -1 and 0. And then the gamma is pretty much the same, highest, most around the strike price. Okay, now that's fine and dandy and all, but there's a lot more variables in our model. And so here we take a look at what is the effect of changes in interest rates. And we see here that our call price D is going to be our default, the one that we were looking at previously. And our call price I is going to be a call option with an interest rate of 1% rather than 9. And we see that for every given stock price, the call price is going to, the option price is going to be lower. Now why is that? Because with the money that we have invested in our option, we could have had that invested into the risk-free rate, which is part of our assumptions. And that would have generated us money. And so the greater the interest is, the greater that time value of money is. And so that's what's going to increase our option price for an increase in interest rate. Did we skip one? Can we go back? Okay, maybe we didn't. Okay. Volatility. Now, what happens when our volatility increases? This is something that I wanted to find out. So here our call price V is going to be our new option with the increase in volatility. And we see that for any given underlying stock price, our option price is going to be greater. Now, why is that? Well, that's because with an increase in volatility, we have a greater chance of large swings upwards. And so that's why it's going to increase our profitability possibly and increase the price as well. Okay. Okay, now what about our time to expiration? What is the effect of having more or less time left on the option? Well, as we all know, options are a wasting asset, which means over time its value decreases. And this is a visualization of that. This is going to be call price T is our option when we have a year 0.2 left, 1.2 years. And then call price D is when we have 7 months left. And so we see here that the call price for the lower time to expiration is going to be less. And that is because there is not as much time for our stock to move. Okay, now let's take a closer look at theta and see what is the effect of theta as our time to expiration decreases. So here we have our 1.5 years we have a lot of time until expiration, it's generally small. Our effective time decay is generally small. And when we get down to maybe 0.3, 0.2 towards expiration, we see that the effect of theta is a lot greater. And so these properties that we've been exploring and looking into, the theory is great, but how can we use these things? This is something that I looked into. So how can we use this information to develop option trading strategies? These are two instances that I've looked into by writing deep into money covered calls. I'm a little restricted on time, so I won't go into it that much, but